Hi all, Nakey here. This is a pinewood pallet. In the industrial area near me there are a bunch of these just laying around, so I thought I might pick one up and make something out of it. My idea is to make a couple of wooden sawhorses. First job is to dismantle the pallet, which means taking out all of these nails. To take off the bottom timbers, I'm going to use this car jack. A couple of twists and the plank goes pop. Easy as pie. Move along to the second one. Get out the screwdriver. Couple of twists later. And pop. Any nails that were sticking up after I got rid of the bottom planks, I'm just going to take out now. After the bottom timbers are removed, it's a simple matter of running along with a mallet and smacking out the top timbers. Easy work. We can move along really quickly this way. Using that method, there was a little bit of damage to the planks. Nothing we can't work around, but there's also a bunch of nails we have to take out. So here's how we do that. Taking the nails out wasn't quite as hard as I thought it would be. All I did was give each nail a couple of taps with the hammer, so the head was sticking out of the back of the timbers. Then all that's left to do is pull the rest of the nail out with a crowbar or a claw hammer. This will leave the timbers nail free with a minimum amount of damage. Now we have a bunch of timber to use. I think I'm going to be able to get about 3 horses out of this. I've also got a couple of spares and broken pieces. We'll see if we can put them to some use as well. A quick measurement of the larger timbers shows that they are 1,165mm long. I'm going to mark them and cut them at nice 500mm lengths, or half a meter. This will come in handy later on. If I ever need to measure half a meter, then the sawhorse is exactly half a meter long. After the 3 timbers are measured up, it's time to get out the big guns, the 1700 watt Nakey circular saw. It's a good idea to remember safety first, so we're going to get out the earmuffs and some eye protection. This is an absolute brute of a saw, so I'm going to be taking it easy, very careful, steady as she goes. Gonna flip the timbers around, mark the excess, and cut that off too. Then after we've finished, we'll be left with 6 pieces that are exactly 500mm in length. This is where a square comes in handy, so we get a nice straight cut each time. Just a little bit too far away from the line on this first run, and I had to walk it in. But after that, everything's fine. So now that the main timbers are cut, I'm going to be grouping them into 3 sets of 2. This will make a really good foundation for the sawhorses. Just to keep everything in place, I'm going to hold them together with this clamp. Well, now that the timber's clamped down and it won't be moving anywhere, I'm going to be using these 50mm screws that I had laying around in the garage. A quick check shows that the screw goes straight through the top timber and just bites into the bottom one. It'd be great if the screw went a little bit further, but that's what we have to work with. I find it's always a good idea to pre-drill even in really soft wood. I think 4 of these 50mm screws should be enough to hold everything together. If not, I can always add more later on. This little Bosch impact driver is going to make short work of this job. As you can see, I'm really ramming these screws down and making sure I embed the head right into the wood. It makes for a flush finish, and I get an extra bite into the timber underneath the first one. A drill with a driver bit would also work well, but I tell you what, I would hate to have to do this by hand with a screwdriver. I think it would take a very long time, either that or it just wouldn't work at all. At this point, some of you might be wondering, Nakey, where's the CNC? I'll tell you what I'm going to be using it for. Sawhorses, well, the ones that I've seen anyway, have angled legs. And what I'm going to be doing is I'm going to be using my CNC to cut a bevel into the main timbers, so when I install the planks, which are going to be the legs of the sawhorses, they're going to be at an angle. Now there are other ways to do this, and I will talk about that a little later in the video, but for now, it's time to get on to AutoCAD. Well, alright, let's do the CAD work. Now we're going to start a new model, of course. The planks that we're going to be attaching to the main timbers are 95mm in width, so we're going to be cutting a 95mm slot into the main timber, and that's going to be our y-axis. Our x-axis is the width of the main timbers, which is 90mm. We don't need much resolution on this, so it's turned way down. Alright, first thing that I always do is I put a rectangle around everything. It's just easier for me to work this way. I'm going to have a width, of course, of 90mm by 95mm. Looks like I got that one perfect. Our center point is going to be 45 by 47.5. Got that one exact too. So I'll create that. Okay. Now, we're going to be using the extruding system in ArtCam, and for that we need what is called a drive curve. So I'm going to put in this one line, and that is going to be our drive curve. Next, we're going to be making a smaller rectangle here, and this of course is going to be 90mm, so it's the entire width of the project, and I'm going to make this 20mm in height. Now, the reason I'm making it 20mm in height will become clear. First of all, I have to make this into a triangle because we're cutting a bevel. So, get rid of that point, and we have a triangular shape. Now, ArtCam doesn't like working with closed vectors. We have to make this an open vector, so we're going to get rid of this span. And that is the shape or the profile that we're going to be putting into our machining area here. Now I can make this anything I want. For example, if I put this over here, it's going to be more of a pyramid shape, but we're going to be going with the bevel shape that I had in the first instance, because that's the best suited shape for the job. Let's align this profile with our job, and that's the reason why I put the rectangle there in the first place. So now I know it's completely aligned and it's going to map the entire job for us. Then we're going to take our start curve and we are going to put it right on the end of this. Okay, now it's time to extrude. Now in my experience this has always been backwards, and I'll actually show you guys this. So if I go to extrude, and you can see this little point that comes out showing that this vector is indeed pointing this way. Here, so we can use that as a drive curve. I don't know if it's going to work out like that, but we'll find out. Here, if we select this as our start profile, we can see the vectors are facing this way. Let's have a quick look and see how it turns out. So we can see that our y-axis, of course, is in line with the little arrow there. So if I hit calculate, that's what happens. Now that didn't work out too well, and I will show you guys why. So we'll back that up. What we're going to do is we're going to make sure this vector is pointing the other way around, so I'll reverse the vector, and I'm also going to reverse this one. And I bet it'll work out this time. So, of course, drive curve, and this one is our profile. Calculate. And there we have it, a profile shape. Now, if I go to the material setup, each timber we're using is 35mm in thickness. Two of them together are 70mm. We're only working with one side, so we can leave it at 35mm, that's fine. The area that we're cutting out is here in the dark grey. We're going to be going right from the top, so it's going to cut straight from the top all the way through. So if we set that up, we can see the bevel we're going to be cutting into the material. So anyways, as I said, it's going to be 20mm in depth, and the reason for that is it sets up about a 12.5 degree angle in the wood. That means if each plank that I'm attaching to the sides of the sawhorse is about 575mm long, I think, if I remember correctly, the distance between the two legs at the very bottom will be somewhere in the realm of 280mm. So they'll be nice and far apart enough to make it so the sawhorses have good stability. Alright, let's do some tooling. So we're going to do the Z-level roughing first, of course. It makes things easier. The roughing tool I'm going to be using on this one is going to be a bowl nose. Now the program's not going to like that, but it'll do it anyway. And I'll tell you why. If I am working with this soft piece of wood and everything goes really fast, I can actually get the Z-level roughing done first, and then I won't have to change the tool when I go and machine the relief in. So we'll just use the ball nose all the way through. Our step over for this one I think is going to be about, it's a 3mm piece, make it 2mm step over. Step down, very soft wood, let's use 4mm. Spindle speed, let's turn it up to full blast and calculate that. As I said, it's going to kick up a stink and say, oh, there's going to be additional material, but that won't matter to us. That's what the Z-level roughing looks like. So now to do the relief machining, once again we're going to be choosing our 3mm ball nose, and this is all set up for wood, by the way. Just make that step over. This one we can make it a 1mm step over. 2mm step down is fine, that really doesn't matter at this point. Feed rate, yep, full blast, and of course our spindle speed we're going to turn right up to full blast as well. And calculate that. That's what it looks like. So let's cut everything out in a simulation. So we'll simulate our first run, which is a Z-level roughing with our 3mm ball nose. Let's simulate the toolpath at normal speed and see how we go. Yeah, I'll speed that up, I think. Maximum speed. And that's what we're left with. That's a funny bit right at the end, but in the end I don't think that's going to matter too much. So the next one we will simulate that. So this is the relief part of it after we've got rid of our excess material. So we'll simulate that. Normal speed, I think. We can speed it up. And it runs through. And that's what we're left with. So that looks like it's going to work out pretty good. Alright, it's time to go to the CNC and get the job done. Let's bring on the Wheel of Pain. So today we're going to be selecting the 3mm bowl nose piece. I think that's going to make short work of this job. So let's get cracking. Here's a little accompanying piece I wrote called I Saw a Horse. While that's on the CNC, let's have a look at the legs. A quick measurement reveals that these timbers are 1160mm in length. So I'm going to divide these timbers into 575mm lengths. This is going to leave a 10mm gap in the middle as an allowance for the saw blade. Now I could have made the length of the legs for the sawhorses anything I wanted. However, we only have a limited amount of timbers that we salvage from the pallet. So, if I pick 6 of the best ones, cut them in half, that's 12 legs I have, which will be enough to make 3 sawhorses. Let's do something different this time. Instead of me writing a whole new backing track to the assembly of this sawhorse, I think I might let you guys listen to some shop noises. Well, there you have it, 3 handy sawhorses for my shop. I'll be able to use these in many future projects. As we can see, I made 2 different sawhorses. The one on the left was made without a CNC, and in another video I'm going to show you guys how to do that too. I'm Nakey, and thank you very much for watching.